Hello, everybody. So the other day we were learning about slope-intercept form, and so I wanted to spend a little bit of time here and get us more used to this because this really comes up in the later grades, and I want to prepare you for that. So yeah, the slope-intercept form, remember, is y equals mx plus b. And m, as it mentions here, is a variable that represents slope. And I don't know why we use m for slope. I even looked it up before this, and the internet says it's inconclusive why we use m for slope. But there you have it. Yeah, so m represents slope, and then this b part would represent where our line crosses the y-axis. So this is the y-intercept, and this is the slope part of it. So that's the slope part. This is the intercept part. And so, yeah, I wanted to spend some time on slope, and we'll do a few problems with it on these notes, and then on some graphing lines as well. So let's go over this. You may have heard the word pitch, slant, or steepness. What do these terms mean? They are words to describe slope. Slope is a ratio that compares the change in vertical distance to the change in horizontal distance. So it's a ratio between these two numbers. And slope can be expressed as the vertical distance. So remember, vertical over the horizontal distance. And so m, is used to represent slope. The change in vertical distance is also called the rise, and the change in the horizontal distance is also called the run. So slope can therefore be expressed as rise over run. And we say this a lot, so I would remember this, and it'll come up a bunch. So I mean, if you forget, no worries, because we'll use it all the time. But rise over run. And I do find that's helpful. Like if we are graphing, you could think about the rise is always you're going to be counting upwards. The run, you're going to be counting to the right if it's positive. So let's do these examples. Calculate the slope in the following situations. And I think all of our wheelchair ramp questions are not, they would not be correct wheelchair ramp ratios. I'm pretty sure that the required ratio is 1 to 12. This one is going to be, I'll show you that this one is going to be 1 to 6, I think. So this would not be, this would be too steep for a wheelchair ramp. So it has a rise. Let's answer the question. The rise of 3 feet and a run of 18 feet. So it's going to look something like this: a rise of 3, a run of 18. So that would be 3, that would be 18. If we put the rise over the run, it'd be 3 over 18. And now we should reduce it. I know that 3 can go into 3 and can go into 18. So I'm going to divide the top and bottom by 3. So we get 1 over 6. That's the slope of our wheelchair ramp, which is not, as I said, regulation. Next, let's do a snowboard jump. Rises 1.25 meters over 5 meters of horizontal distance. So it goes up by 1.25 meters over 5 meters of distance. So that would be 1.25 over 5. And each of these, I'm pretty sure 1.25 goes into 5 4 times, but we could do it as a decimal if we wanted. So we could go 1.25 divided by 5. That gives us, 1.25, which is 1 over 4. You could also show it, if you want, as a decimal. Okay, let's do the next one. We're just doing rise over run. So a roof rises 8 feet or over a horizontal distance of 18 feet. So we got probably a house that looks like this. And we have an 8-foot rise, 8 feet. And we could say that the run that way, and will probably be that way as well, would be, down here, 18 feet and 18 feet. I mean, who knows what the building looks like. But essentially, we have a rise of 8 over a run of 18. We can reduce each of these by 2. We get 4 over 9. I'll do the last two. A hill rises 10 meters over a horizontal distance of 8 meters. So this one, we have it. It's quite steep. We could say 10 over 8. So that's 10 over 8. Divide top and bottom by 2. And we get 5 over 4. And I'll do the last one. A slide covers 3 meters of ground. So this one gave us the run first. That's 3.5 meters and is 2.4 meters tall. So our slide looks something like that. There's the slide. You can imagine, okay, it goes down in a cool little curve like that. So the rise, this part right here, is 2.4 over 3.5. Okay, for the next part of the notes, maybe you can give this a go yourself. So it looks something like this. I should probably change the values of this because this is also just ridiculously tall as well. Let's do 5 feet and let's do 50 feet for this one. This would be a way too steep distance for a wheelchair ramp. So let me change that. And then let's also do, again, 5 feet. And let's change this one to maybe like 65 feet. And remember, I think the regulation ratio is 1 to 12 or 1 over 12. So you're looking for at least this for your wheelchair ramp. Answer this question as well. Which one would you choose? And then answer number 2. So you're biking and there's 2 different elevations over certain distances. Which one would you choose? This one's a little bit more subjective than the first one, but try those on your own. And there's one more thing that I want to do. So I'll pause the video now and I'll just move on. But I want to show you or give you a little bit of instruction for this as well. So hopefully I've paused. I'm continuing on. Here we go. Make sure you got your name on this. And there we go, Allie. And so for each of these, I want to show you how you do this now. Now we have our slope-intercept form. And so we have this part that represents the slope, what we were just doing, the rise over run. And we have this part, which represents where our line crosses the y-intercept. So let me graph this one for you. So let's start with where it crosses the y. So it's going to be right here at -1. And now the slope is going to be a rise of 1. It's 1 over 4, and a run of 4. So we're going to go up 1 and right 4. Up 1, right 1, 1, 2, 3, 4. There's our first dot. Our next one's going to be off the page already. We're going to rise 1 and run 1, 2, 3, 4 over there about. This one, to get back here, you can think about how -1 over -4 would equal 1 over 4. If we have a +1, we go up, and if we've got a +4, we go right. So if we're going to do the opposite, we've got a -1, we go down 1, and our -4, we go left 4. 1, 2, 3, 4. So there's another dot. We do another one, down 1, over 4. So something like that is what our line is going to look like. Let me do 2. So now we have a -x, which would be like -1x plus 2. So it's kind of like a -1x. You can imagine it over 1. So let's start where it intercepts the y. And then let's do our -1 since it's negative. Okay, let me just do this negative. Looks like a R. So let me do positive equals up, and it equals right. And negative equals down, and equals left. So we have our -1, and our run, +1 is going to go right. Then we've got our down 1, right 1, down, here we go, down 1, down 1. So it's going to go up this way. And remember, the opposite of this one, we did up would be left, up would be left. And you can kind of see the pattern. Oops, I just deleted that. So we can connect them like that. Should I try any other ones, or the ones that you might need help with? Let me do number 5 for you. So let's look first where we're going to cross our y-intercept. So it's going to cross here at -3. Then we've got a -3 over 1. So we're going to go down 3. That's a -3. 1, 2, 3. And the 1 is positive, so we go to the right. Now, since we're off we'd be way down here, let's do the opposite. So we're going to flip it. We're going to think about it also equaling 3 over -1. So instead, let's count up 3, 1, 2, 3, and left 1. 1, 2, 3, and left 1. 1, 2, 3, left 1. So there you go. There's that line right there. Okay. I will stop this. Thank you very much.